Hi guys. In this video I will cover the nomenclature of alcohols and ethers. Okay, we saw alcohols in Organic 1, of course, plenty of times. The alcohol is the carbon group with an OH, the hydroxyl group. Hydroxyl. Okay, not hydroxide. Hydroxide is OH minus, the anion. Okay. When it's neutral, when it's bonded to the organic fragment, we call it a hydroxyl or hydroxy group. Okay. The R group, of course, R being a designation for carbon group, is very often sp3 carbon. When it is, we call those alcohols aliphatic. That's an old term for saturated. When it's bonded to an sp3 carbon, an aliphatic alcohol. The OH group can also be bonded to an aromatic ring, and that's typically known as a phenol. Now, the most common aromatic ring is the benzene ring, and here we see the structure of phenol itself, but you could have other substituents here, and it would still be a phenol. We'll look at phenols more in detail during test 2. By the way, these others down here are all aliphatic alcohols or saturated alcohols because the hydroxyl group is bonded to an sp3 carbon. We will get there. Before we get there, though, let's point out this type of compound where the hydroxyl group is bonded to an alkene. Now, as we saw in Organic 1, this is known as an enol. Okay? Because the alcohol is bonded to the alcohol group, the hydroxyl group is bonded to the ene, the alkene. Now, enols are often and usually not stable. They often undergo tautomerization to a carbonyl compound. We will see that again during test 4 material here in this course. Some enols are stable though, and I will actually show you a couple of stable enols when we get to test 4. Okay. We need to point out this terminology, primary, secondary, tertiary alcohols. Ethanol, and we'll learn why this is called ethanol below, but ethanol is an example of a primary alcohol because the hydroxyl group is bonded to a primary carbon. That carbon is bonded to only one other carbon, and thus it's primary. We can designate that with the word primary or just the sort of the one alt. Isopropanol here is known as a secondary alcohol because it's bonded to a secondary carbon, the hydroxyl group is. And tert-butanol, the hydroxyl group is bonded to a tertiary carbon, which is why it's called a tert-butanol or tertiary butanol. Okay, so primary, secondary, tertiary terminology is important, and we will classify alcohols that way quite often. Okay, let's look at the nomenclature of alcohols. How do we name them? This primary alcohol here. Well, as you'll see with all of our nomenclature as we continue moving forward, it's all sort of consistent with how we named alkanes. We want to identify the longest continuous chain, and then we're going to replace the E, because if it was an alkane, we might call it butane or heptane, ending in E, but we're going to replace that E with, in this case, an OL, indicating we have an alcohol as our primary functional group. Longest continuous carbon chain, okay? Carbon chain. In this compound here, we have 1, 2, 3, 4. There's no other chain there, so we have a butane, but we're going to replace the E with OL. And the name becomes butanol, with the OL indicating the 4-carbon has an alcohol group on it, essentially. All right. Now, by the way, let's move ahead to this structure. What's the name of this compound? It's an alcohol. We can name it as an alcohol. These are constitutional isomers, yeah? Longest continuous chain here, butane, 1, 2, 3, 4. There's no other carbon chain. Also butanol, but they can't both be called butanol. What we do here is we have to indicate where the OH group is located. And in the first compound, it's located at the 1 carbon. Okay? This is 1, 2, 3, and 4. Since the OH is at the 1 carbon, we call this 1-butanol. The 1 indicating where the OH is located. So what do you want to call this alcohol? It is a butanol. You've got butanol isomers. But this alcohol we're going to call 2-butanol. Okay? The numbering begins with the end nearest the OH. This is the end. Okay, the end nearest the OH. Which end is nearest the OH? This one. 1, 2, 3, 4. The hydroxyl group is at the 2 position. 2-butanol. Question. Could we have a 3-butanol? What if the OH was here? Is this 3-butanol? No. These are the same because this compound, this is the 1, 2, this is the same compound. It's just turned around. If we name this according to our directions here, we would see that this is 2-butanol. And if compounds have the same name, they're the same. Now, as a side point, this alcohol is chiral because the carbon here is chiral. This could be, you could have stereoisomers here. But if shown generically, they're the same. Okay, next compound. Main functional group is an alcohol. Longest continuous chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Either way you go, it's 5. Or we could do 1, 2, 3, but 5 is longer. We can circle this here. Doesn't matter which way we go. We can either enclose this in the longest chain or we could have enclosed that. Either way, this carbon's going to have a methyl that's not in the longest continuous chain, yeah? Okay, longest continuous chain is 1, 2, 3, 4, 5. It's an alcohol. That would be not pentane, but pentanol. The OH group is at the 1, 2, 3, 4, 5, 2 position with 2-pentanol. But in addition to that, we have something on our 2-pentanol. We have a methyl group also at the 2 position, 2-methyl 2-pentanol. And so the subs get lowest numbers. But this is a lower priority. The first priority is essentially for your OH to get the lowest number, because you need to begin with the end nearest the OH. Now the carbon that the OH is on is not 1, it's the end nearest that. Okay, so this is a good name. This alcohol is not chiral because that's not a chiral carbon. We could have enantiomers possible here, and we would designate those with R and S depending on the stereochemistry if that was given. I'm just sort of giving you a little bit of extra information here, reminding you about chirality here since we have a chiral alcohol. But these two are not chiral. Let me also add this. This is IUPAC nomenclature. Typically, we indicate functional groups by the change in the suffix here. Another way to name these alcohols is we can call this a butane and say 2-hydroxy butane. And I only point this out because, first off, that should make sense. We've got a butane there and at the 2 position. Just like if we had a bromine here, we would call it 2-bromobutane. But this is not IUPAC. Okay? IUPAC is for alcohols, and for most compounds is where we change the suffix to indicate the functional group. All right? Now, the OH is on a ring, but it's not aromatic, okay? That's an aromatic ring. This is not. These are named sort of, well, just like here we said butane, and we changed it to butanol. Here we have a cycloalkane, cyclohexane, but we're going to replace the E with OL. All right? And that's cyclohexanol, shown there. We just have a chlorine on our cyclohexanol. Now the 1 position here by default is the carbon that contains the functional group substituent. All right? Because there is no end in the ring, so by default, that's the 1 position. Then we want to give subs lowest numbers, and so we go this way to 3, and this would be 3-chloro, okay, cyclohexanol. That's all one word. We would not want to put a hyphen here. We're only going to put hyphens when we have to offset sort of numbers here. 3-chlorocyclohexanol would be the name of that compound. Okay. Now if you want one to work on, let me just draw one out here and we can do it maybe in class. Doop, doop, doop. Let's put an OH here. Doop, doop. Doop. And we can put maybe a fluorine here. Let's put one more carbon here. All right, not connected, there's no ring. So there's one you can practice on. Name that compound. Okay. Nomenclature of ethers. Now, ether, of course, is the oxygen not bonded to one R group, but bonded to two R groups. Okay? Over here, we could have said the oxygen is bonded to one R group. Oxygen bonded to two R groups is an ether, of course. The R group can be sp3, of course. It can also be sp2. It can actually also be sp, but that's getting a little bit rare. What especially we want to make sure that we know that it can be sp2 or even an alkene here. Okay? Regardless, it's always an ether. Over here, we change the name to phenol or an enol. We're not going to change the name with the ethers. Any of these would be an ether. Okay, some terminology here. We can have symmetrical ethers, such as diethyl ether. It's symmetrical because the R groups are the same, both being ethyls here. Or it could be non-symmetrical. In this case, the R groups are not the same. We have a methyl and we have a tert-butyl. We can also have cyclic ethers. Now you might call this a cyclic alcohol. Over here, perhaps. I don't know that I would say that. The oxygen, the OH, is bonded to a ring, but the oxygen is not part of the ring. It can't be. If it was part of the ring, it couldn't have an H on it, and it would no longer be an alcohol. But with ethers, the oxygen can be part of the ring, or a ring. Oxygen, this is a 5-membered ring, 4 carbons, 1 oxygen, making up the 5-membered ring. That would be called a cyclic ether. Now this is actually known as tetrahydrofuran, or the abbreviation THF. THF is actually a common solvent used in the lab. We'll mention this at some point during lecture because it's useful for making Grignard reagents. Okay, nomenclature of ethers. Now actually here we don't use a suffix. Here we use the word ether. 3 words. We note the 2 alkyl groups and then we say ether. All right, it's rather simplistic. For example, up here, this compound, let's name this compound. Okay, what are the 2 alkyl groups? Well, they don't have to be alkyl. What are the 2 carbon groups? Methyl, okay, and tert-butyl. That is a tert-butyl group. You should have seen that in Organic 1. All right, those are our 2 groups. We're going to state those and then add the word ether. 3 different words. All right, we're going to put these groups in alphabetical order. I am using a common name here. Methyl and tert-butyl. Okay, whenever you do a hyphenated prefix, whenever there's a hyphen, you don't include this in alphabetical here. We look at the B. This is methyl. A B should come first. So this is tert-butyl. Then we say methyl. Then we say ether. 3 words. Tert-butyl, methyl, ether. Now, This compound is actually known as MTBE. That stands for methyl tert butyl ether. Unfortunately, in the literature, well, not the literature, but in the media, somehow they placed the methyl before the tert butyl, probably because they thought that you should alphabetize this according using the T, but that's not right. It's known as MTBE, and that name is unfortunately stuck, and you'll see it like that. But that's because they have placed the methyl first, then the tert butyl ether. We see this a good bit in the media literature because it used to be an additive for gasoline. It's common these days to have an additive for gasoline which contains oxygen. Because typically gasoline is just hydrocarbon, like octane, just all hydrocarbon. If we add oxygen into the mixture when it burns or when it undergoes combustion, the presence of that oxygen intimately in the molecular structure helps the combustion and helps the gasoline burn better and reduce certain emissions of, for example, carbon monoxide, and just sort of helps with the combustion and the gasoline engine running better. Today, we add ethanol as an additive up to 10%, which you see on your gasoline pumps. MTBE was sort of banned because it started causing problems, getting into water runoff. It's quite smelly, and so ethanol is seen as a better alternative, and so this was phased out. Okay, that's nomenclature there. That one. We'll do examples below. By the way, tert butyl is a common name. Okay, we may come back and name this using a fully IUPAC name. But let's go down here. Okay, we look at this compound here and we see we have an ether. Now, alkyl chloride, usually halogens, alkyl chloride, that really doesn't take precedence over ether. All right? Very often halogens are just named as substituents. We can discuss that more. How can you name this ether? Well, what are the two R groups? On the right side here we have 1, 2, 3, 4. We have a butane. All right. But the butane has butyl has a chlorine. So what's the name of this group? Well, importantly up here, the one position of each group on the ether begins closest to the oxygen. So just looking at this R group here, this is the 1, 2, 3, 4. We have a butyl with a chlorine at the 4. So this is going to be called 4-chlorobutyl. Now over here, we can go ahead and name that 1. Longest continuous chain, 2. And then either way you go, 3. I'll go this way. It doesn't matter. We could have went that way. So we have a propyl, but there is a methyl on the propyl, and it's at the 2 position. 2-methyl, that's all one word, propyl. Here are our first 2 words, then we're going to say ether. Now, alphabetical, C comes before M. So the name of this compound is 4-chlorobutyl 2-methyl propyl ether. And that's the name of the entire compound. 3 words. Each R group named. The R groups are longest continuous chain, carbon chain, and then there may be something on that chain. The numbering of this substituent or this R group begins at the carbon bonded to the oxygen of the ether. Okay, name this one. Well, that's a methyl. This is a benzene ring. A benzene ring is named a phenyl whenever it's named as a substituent. M comes before P. This is methyl. Phenyl. Ether. 3 words. Now later on we may see substituents on the phenyl. We could just add substituents. We would know that that's the 1 position. If a substituent was here, that would be the 2 position. But we'll look at that actually during test 2 when we look at the chemistry of aromatic compounds and the nomenclature of aromatic compounds. By the way, we will also see that a lot of, or a variety of aromatic compounds have common names, almost as phenol is sort of a common name. Basically, this is phenol with a methyl. This has a common name of anisole. You do not need to know that common name now, but you will during test 2. All right. How about this ether? This is a symmetrical ether. When the ether is symmetrical, you can use the term di and to indicate the name of the single substituent. This is a cyclopentane, so it's a cyclopentyl dicyclopentyl ether. So it's actually only 2 words because we didn't say cyclopentyl ether. You can combine the 2 and just say di. We don't need to worry about 1 position, but of course if we did, that would be 1. If there was a chlorine here but not here, then we would have 2 different substituents. It would be a non-symmetrical ether, and then we would need 3 words. Now we actually saw back up here a symmetrical ether, and we called it diethyl ether. And hopefully you see why it's called diethyl ether. And of course, diethyl ether is another actually very common solvent in the laboratory. It does have a few issues though. That diethyl ether is sort of not an entirely so-called green solvent. So more and more it's being sort of phased out, especially on industry scale. Research scale, it's still very, very commonly used, but in large scale applications, there's better alternatives. It's got a very low boiling point, so it evaporates a good bit and gets into the atmosphere. It also causes or forms peroxides very easily, and peroxides can become explosive. And so old jugs or cans of ether sort of can be hazardous because they have a buildup of peroxides. So there are some sort of alternatives, but at the intro level and at the small scale level, it's still a very commonly used solvent. Now, of course, 100 years ago, 150 years ago, diethyl ether used to be used as a general anesthetic to sort of sedate people or knock them out. So could do surgery or something, and it was used a good bit like during the Civil War for that purpose. Okay. If you like to try your hand at another ether, of course, there should be plenty of examples in your textbook, and that's where I mainly expect you to be looking. In fact, I'm not going to give you another one to do here. I want you to go to your textbook, and you need to be working, nomenclature problems there, and of course, all types of problems as we get into reactions of alcohols and ethers. Need to make good use of your textbook. Okay, did we cover everything here on the nomenclature of alcohols and ethers? We'll see if you have any questions during the lecture at some point. Okay, guys, that was the nomenclature of alcohols and ethers.